A rare nova ignites a new star in the sky, offering a once-in-a-lifetime stargazing opportunity. This rare space phenomenon occurs when a white dwarf star and red giant are close together. As the red giant sheds its outer layers, the white dwarf absorbs that matter on its surface until it eventually overheats, triggering a thermonuclear reaction, also known as a nova outburst, according to NASA. An astronomer said, "This celestial event is different from a supernova, which is the complete detonation of a white dwarf. In this case, a nova outburst is a surface explosion, and the white dwarf stays behind, allowing another blast in the future." This recurring nova is only one of 5 in our galaxy. This happens because TCRB is a binary system with a white dwarf and red giant. The explosive stellar pair consists of a white dwarf, a relatively small, dense stellar remnant and a larger red giant star in the late stages of stellar evolution, meaning its outer atmosphere is inflated and tenuous. The gravitationally bound stars are close enough that, as the red giant grows unstable from its increasing temperature and pressure, it ejects its outer layers onto the white dwarf. The accumulation of matter heats the white dwarf's dense atmosphere enough to trigger a thermonuclear reaction that produces the nova we see from Earth. This cycle will continue once the nova dims as well, with the white dwarf collecting enough matter to create another outburst. The outburst, expected between February and September 2024, will be visible in the Coronae Borealis constellation and may shine as brightly as the North Star for about a week before fading. In October 1217, the abbot of the Erzberg Abbey, in present-day southern Germany, looked to the firmament and, in the arc-shaped constellation Coronae Borealis, saw something wondrous. It was originally a faint star that for a time shone with great light and then returned to its original faintness, he wrote in Latin at the time. He wasn't the first to see it, nor was he the last. This stellar apparition emerges, then vanishes, every 80 years or so, and that's because it isn't really a star at all. That abbot witnessed a thermonuclear explosion 3,000 light-years away. It came from a white dwarf, a stellar zombie that's devouring matter from a nearby red giant star. Once a century, it gets full, and when it does, it erupts, unleashing a week-long hellfire. This year, the event will be caused by the binary star system T Coronae Borealis, where a white dwarf star will trigger a bright flash of nuclear fusion, after siphoning material from its red giant companion. This far-distant stellar system is situated around 3,000 light-years away from Earth and is usually much too dim to be seen with the naked eye. This year, however, T Coronae Borealis is expected to explode for the first time since 1946, briefly shining brighter than the North Star Polaris, according to NASA. T Coronae Borealis is a recurring nova, one of only 5 known to exist in our galaxy. It is actually 2 stars in a binary system, comprised of a white dwarf and a red giant orbiting each other. Red giants are stars that have exhausted the hydrogen fuel in their core. The core contracts and heats up while the outer layers expand and cool, causing the star to swell in size and become a red giant. The outer layers of a red giant are cooler, giving them a reddish appearance. Meanwhile, white dwarfs are the remnants of stars that have exhausted their nuclear fuel and undergone gravitational collapse. They become incredibly dense, typically with masses comparable to the Sun but squeezed into a volume roughly the size of Earth. T Coronae Borealis goes nova once every century or so as a result of a special property of the white dwarf red giant system. The white dwarf slowly strips away the atmosphere of the red giant, absorbing hydrogen into itself and getting bigger and hotter. Eventually, it heats up to the point that it undergoes a thermonuclear reaction, exploding in a massive burst of light. This is a nova, which is less powerful than a supernova, as supernovas completely destroy the star. The white dwarf is much smaller and much more compact, so you build up a little disk of mostly hydrogen and maybe some helium as well sitting on the white dwarf, Jonathan Blazek, an assistant professor of physics at Northeastern University, said in a statement. Eventually enough of it builds up and basically ignites. It's not literally burning in the sense of fire, it's thermonuclear burn and you have hydrogen undergoing a fusion reaction. Eventually, you build up enough mass on usually the hotter object that it ignites. In this case undergoing fusion, and then suddenly you get a very rapid release of energy, so it gets much, much brighter, he said. When astronomers are lucky, they find recurrent nova, those that erupt at least once per century, as predictable beacons for their studies. Including T Coronae Borealis, they've only managed to find about 10 in the Milky Way, however. And despite T Coronae Borealis' apparent clockwork-like dependability, astronomers of yore have proved fickler. The system's eruptions have only documented for the years 1217, 1787, 1866, and 1946. Based on subtle details observed during its prior two recorded outbursts, the official prediction is that it'll go off this year, and it should be visible for several days. This once-in-a-lifetime event occurs approximately every 80 years and presents a rare chance for skywatchers to witness the phenomenon. Look up after sunset during summer months to find Hercules. Scan between Vega and Arcturus, near the distinct pattern of Corona Borealis. Once you find its stars, use binoculars or a telescope to hunt down the globular clusters M13 and M92. If you enjoy your views of these globular clusters, you're in luck. Look for another great globular, M3, in the nearby constellation of Boötes. When the red giant moves behind the white dwarf, a nova explosion on the white dwarf ignites, filling the screen with white light. After the light fades, a ball of ejected nova material is shown in pale orange. A small white spot remains after the fog of material clears, indicating that the white dwarf has survived the explosion. The star system, normally magnitude +10, which is far too dim to see with the unaided eye, will jump to magnitude +2 during the event. This will be of similar brightness to the North Star, Polaris. The star system consists of a red giant star and a white dwarf that orbit each other. The red giant continuously feeds the white dwarf with its stellar fuel, hydrogen. When enough hydrogen accumulates on the white dwarf, it undergoes a thermonuclear explosion. This causes the star to brighten dramatically and is what scientists call a nova. Every 80 years or so, this system puts on a dazzling nova display, with the last eruption occurring in 1946. Now astronomers predict another outburst is imminent sometime between February and September 2024, NASA explained in a statement. The outburst will appear as a bright, new star in the night sky.